Okay, I'm fond of pacing, so I assume people in the back can hear me because I borderline shout in my day life anyway. I'm Roy, I work at Netflix, and I'd like to talk about sort of the way we think about operational insight as a sort of holistic model. This is, by the way, not the way to think about operational insight. I'm not here to give you religion. This is just our way, and by the way, our way is not better than any others. So, brief introduction to Insight Engineering at Netflix. We're a software engineering group. There's about 17 humans and 3 headcount that are still open. We are composed of 2 groups under me. One is telemetry engineering. The other one is called fault detection engineering. I'll talk about what they do. My systems are the single largest cloud spend item for Netflix. It's been said that Netflix has actually built a fantastic monitoring company that happens as an accidental sort of emerging design pattern, also stream content. Our charter is pretty simple. It's real-time operational insight. Those 4 words all matter. So real-time means that we really only care about the next few minutes to few hours. We're not trying to figure out what we're going to do operationally in a year. From an operational perspective, we care about operations. So keeping things going, deploying stuff to the cloud, all of that stuff. You don't care about buying content or deciding how much people are going to get paid. We'd like to have some input into that sometimes. Insight is actually important. We used to be called monitoring. But the thing is, we're actually trying to provide, a useful sort of meaningful insight into what's going on, rather than simply providing people a bunch of data or credits. So what that actually means is that my group is providing the system to help us do a bunch of things. One of them is to actually figure out some version of, is it done? So when you're deploying software, you're trying to figure out if it's working the way it should, then you use our telemetry platform. If you're trying to fix a performance problem and you're trying to figure out whether or not that was successful, you use our telemetry product, etc. So this is all the happy path stuff, right? But we are also the smoke. So we are the people who are going to use PagerDuty APIs to wake you up at not 2 o'clock in the morning. Our worst times are actually about 4 p.m. to midnight local time, because that's the busiest time. But we will notice the smoke and we will follow up on that by alerting the right people. When things really fail and Netflix is on fire, we are the ones who should be able to tell Netflix how hot it is. Netflix has several tiers of services. Tier 1 are services that are absolutely critical for streaming. Tier 2 are services that are important for streaming. Everything else is basically untiered. Some services in Netflix are considered Tier 0. Monitoring and alerting are actually a Tier 0 service. There are people I've talked to at Netflix who believe that if we ever had to choose between keeping monitoring going and keeping the product going, we should take down the product, because it'd be better to actually be able to measure how much we're disappointing our customers than to serve our customers and not know how well we're doing that. I'm not sure. By the way, is there anybody here who's a Netflix customer? Yeah.
Well, not after this.
We're not important.
There's no. By the way, this is not an official stance. So this is just an interesting sort of hypothetical argument within the company.
Well, we should all be monitoring customers.
Yeah, there we go.
And then, ideally, of course, this is when things go terribly wrong. But when we build our systems correctly, we don't just tell the company to fire. We also are able to use basically automated fire extinguishing systems to take out the fire automatically, because this is way better than sending humans into the fray. So, from a model perspective, what does it all mean? So, let's go back to probably one of the most important events for everybody in this room. The Korean War, 1915 to 1950.
All about.
Was there an AWS outage that caused that?
So, in the Korean War, there were a bunch of dogfights between MiG-15s from China on the right side, F-86 Sabres on the left side. One of the pilots involved in those was a guy named John Boyd. some people in the audience are probably seeing where this is going. And he basically did a study of a bunch of dogfights and came up with this model for how dogfights happened, which was that, let's say you're a fighter pilot flying out there in the sky, in a plane, hopefully. And you're looking around you, and you might notice that there's another plane out there. And that doesn't actually have any meaning, right? It's just factual. Then you're trying to figure out, like, what does it mean? So you're trying to sort of deduce some important factors in that observation. For example, are they flying toward you or away from you? Are they an enemy plane or a friendly plane? If they're an enemy plane, do they have like 5 or 6 of their closest friends with them, also in planes? And once you orient and try to and figure out what this means, you make some sort of decision. I'm going to run away, I'm going to engage. And once you've made the decision, you're going to act, and then you're going to go back to observing to see what happens next. If I've decided to run away, are they flying after me? That's an important thing to know. If I've decided to engage, have they noticed me? John Lloyd noticed that this basically spells Buddha, and this is in fact the name of the sloop. And a bunch of people have basically referred to the OODA loop in the context of human conflict, because John Lloyd observed that whichever fighter pilot processed the OODA loop faster, basically went through this loop faster than the other person, that was going to be the person who was most likely to get home that day. The thing is, this is not actually just the case for human conflict. This is actually what we all do in our regular lives. Because if I'm a software engineer, for example, and I have written some code that I want to deploy into production, then I might deploy that code into production, and I might observe how it's doing. I might figure out whether or not it looks good. If it doesn't look good, I need to make some decisions about what I'm going to do about that, and then I'm going to act on those decisions and see if I've resolved the issue. Who here does any sort of like ops? Yeah, so think about ops, right? What we do is we observe what's going on in production. And the fundamental question we're trying to ask is everything okay? Or am I screwed again and I should cancel dinner? Especially if I look at picture. And if there's a problem, what should I do about it? Once I make a decision, I'll act on it and see, did I make it better or did I make it worse? And then I observe and I go back, and at some point I might update my resume, etc. So, from our perspective, this ends up actually mapping to some systems and capabilities pretty nicely. So for observation, we have telemetry platforms. I'll talk about that in a second, but for telemetry platforms, I'm really talking about, think of them as specialized databases. You send a bunch of data in, for example, time series or events, you get a bunch of data out. These systems do not make decisions, they don't add meaning, they're just basically data in, data out systems. To figure out what they mean, we humans typically use pictures better than words or numbers, because if I want to look at my server CPU over the last day at 1 minute granularity, I'd rather see a graph than 1,440 numerical values. So you've got graphs and dashboards. And then in order to make decisions, you have alerting systems. Who here has an alerting system? Okay, everybody else who didn't raise their hands either has a problem or you're just not playing well. And then in addition to alerting systems, of course, you also have decision output systems. We call those typically human beings. And then once a decision is made, you've got to deal with typically remediation, which is, again, in most cases, done by human beings, courtesy of XKT. What this ends up being translated to in our production environments, it looks like something like this. So this is OODA at Netflix. The asterisk here is because you could actually say that everything at Netflix is OODA, but this is really real-time operational insight OODA at Netflix, not how we figure out how to buy the second season of Iron Fist or something like that. So from an observation perspective, we have 3 primary telemetry platforms. Atlas, which we've open sourced, is our in-house time series database. It currently logs up to about 3 billion time series, and about 2 billion of them are being updated on a per minute basis. We have basically different tiers that hold different granularity of data. So we have a 6-hour tier, a 3-day tier, and an 18-day tier. You'll notice that implicit here is the statement that we do not actually have real-time availability of telemetry data, of Atlas data, for more than 18 days ago. We've actually generally found that in order to deal with real-time operational insight, if you're doing things the right way, you usually don't actually need to go more than about 18 days back with time series. We do actually hold all the information indefinitely in S3, so we have information going back to 2014. It's turned out to be kind of useful, so our BI people end up using that data for a bunch of non-real-time reasons. It's custom software. We've open sourced it. It is. I think I prefer to use the word hideously expensive, to be perfectly honest. In order to support all of the queries against this, and the SLA that we have, which is about 99.995% of the queries returning within 5 seconds, all of this data is in RAM. And so we are limited by RAM on machines, and that means we have a whole bunch of Amazon instances. I go back to that all my systems are most expensive single items for efficacy at AWS. Kronos was built by us to answer the age-old question. So somebody just shout out, what's the first question you ask when something goes terribly wrong in your environment?
Whose fault is this?
What changed?
So the way to deal with changes, of course, in most environments is to do change management, right? So you have an engineer submit like some sort of ticket where they say, I want to do this, and maybe they get permission and approval, and then they log what they did, and that's like, I don't know anybody who loves change management systems. So we moved away from that. This is our change reporting system. It's entirely automated. You could interact with it, if you wanted to, by like sending REST calls into it. But basically, what we've done is we've taken every system of Netflix that mutates production in any way and instrumented it to send a mutation event into Kronos. So Kronos is now the automated source of truth for what changed in production. The good news is Kronos never lies. Do something at midnight, but you did it at like 11:57. Kronos knows. If you thought you were going to do something at midnight but didn't get around to it, Kronos knows. And the good news is we don't really care what you wanted to do. We're actually reporting on what you did because we're capturing that automatically, which also, by the way, means we're not relying on you to be correct. We keep retention for Kronos for about 18 months for 2 reasons. One, it ends up being kind of useful because this is what you can use to answer questions like, for example, how often do I deploy? Or how often do I deploy and then roll back? And frankly, the data in Kronos doesn't cost nearly as much as Atlas, so you can actually hold a much longer retention period. This is not custom. This is basically a relatively thin layer of REST on top of Elasticsearch. This is just a quick look at this. This is 1 hour that I captured. I'm not saying I worked on this last night, but I captured this last night. So this is from now until an hour ago, and you can see that we had 6,358 events in production. These are the applications responsible for most of them. This is sort of like the heat map, and I cut this off, but you can actually see the list of events, and you can drill in, and you can do a bunch of searches, etc. Super useful if you want to answer the question, what happened? It's worth noting that this is only really relevant if, like us, you happen to be the sort of company where most of your outages are self-caused. If you've gotten to the point where most of your outages are not caused by your own changes,
Does that mean you made 1,300 changes in an hour?
that
Or
means
that's top one?
1,300, yes, 1,300 changes in an hour. This one made 1,100 changes in that hour, etc.
But those are not human driven, right?
No, especially because I'm not saying I was doing this last night, but that was like 1 a.m. last night. This is a whole bunch of automated systems. Lastly, we're a microservices environment. We have like 2,000 microservices. And while it's always very attractive to put somebody on the task of basically graphing dependencies between services and that diagram,
Punishment duty. The person whose fault it was.
we prefer to think of it as hazing. What we've ended up doing is building this service called Self. It's based on Google's Dapper paper. Zipkin is actually a similar sort of capability from Twitter. It's a distributed tracing system. It helps us do dependency discovery. We've actually done some really interesting things on it because it ends up being a super useful source for chaos exercises. And it lets you do interesting graphs that are completely useless like this. There is actually a way to expand this, but then I actually have to expose service names. we get cranky about it. So that was for observation. From an orientation perspective, you've already seen actually a bunch of UIs that we've created that were sort of custom designed on top of those particular telemetry platforms. We also have a product called Lumen, which we built. It's an extensible dashboard system. So this is super hard to see. If people are interested later, and I can get on the internet, I can show some examples. But it lets you create a dashboard with a bunch of different data sources and a bunch of different sort of ways to look at those data sources. So that's just like tabular data. These are graphs. You can use a bunch of different visualization capabilities. In order to build a dashboard, you just need to know how to use JSON, and we even warn you of that formatting. We built this for real-time operational insight, but it turns out that when we build real-time operational insight systems, people find really interesting ways to use them. So it turns out that our BI people have started using them as a primary way to create BI dashboards. It's easily extensible for both data sources and visualizations. So a new data source, assuming that it does REST, can typically be integrated into this in about like 2 to 4 hours of work of building a job description. Same thing about visualizations. For decisions, obviously we have alerting. We have both simple alerting, which is, hey, employee deferred, here are some alerts that we would like to recommend adopt. And it's easy to opt into those. From a non-simple perspective, you can simply define your own alert query against our Atlas. Atlas has this incredibly powerful language called the Atlas Stack language, which is an RPM, reverse multiplication language. It was built to be incredibly powerful, and it's really wonderful for the PhD who wrote it and other machines. In addition to alerting, we have outlier detection. So say you've got 100 web servers. They're all running the same kind of hardware. They're all running the same software. It turns out that it's actually not that difficult statistically to deduce what the right herd behavior is and to figure out whether or not you have outliers. And once you have outliers, you can essentially ostracize them and do whatever you want with them. We call this the high school algorithm. Yes, I'm bitter. And it turns out to be relatively useful for large clusters at Netflix. In the last 7 days, we've actually automatically killed about 600 or so instances based on outlier detection tagging. And lastly, we have automated canary analysis, which automates this whole process of I deploy some new piece of software. Is it at least as good as the previous version of the software? It integrates nicely with our orchestration systems to automatically deploy or roll back. So that's on the decision process side. Meanwhile, we're actively working on both univariate anomaly detection and multivariate anomaly detection. Those are interesting, meaty, and super, they're hot and attractive, and we're still figuring out how much value there is and how easy or hard it is to generalize them. This is what happens, by the way, when you have an infrastructure group that has data scientists. So, in terms of actions, once you define basically some sort of decision, these are some possible actions you can take. You can send an email. You can send a page via PagerDuty. There are some interesting historical reasons why we have those as separate. You can deactivate an instance in our discovery system, take it out of ASG or ELB, you can remove a terminated instance. Winston is our in-house runbook automation system. It's built on top of Stackstorm. I'll show a quick picture of that in a second. Or if you want to integrate with any other arbitrary system in Netflix, you can simply send it to an SQS queue, and then the other system will just consume that, or you can even do a Jenkins action. This is Winston Studios, something we built on top of Stackstorm. It lets you basically define a runbook action via, this is Python, but we also support So, that's basically it for us, right? So for Observe, we have telemetry platforms, Atlas from SL. We have some interesting graphs and dashboards for orientation. We've basically made machines do all the hard work of alerting, outlier, anomaly, and canary analysis detection. And then we've apparently recruited some science to actually do remediation. This mostly works pretty well for us, except for when they get freedom. Do I have time for questions?
Yes.
Good. That was super fast, and there's like days of detail there. Is there anything I can tell people that I haven't already told? Yeah.
You talked about automatically killing machines if they're an outlier. Do you go back and analyze why it was an outlier? In fact, or?
So the question for people who didn't hear it is, once you've killed a machine because it was an outlier, do you go back to analyze why the heck it was an outlier? No, and one of the reasons for that is, first of all, we are, the last official number we talked about publicly was that we're running more than 100,000 servers in AWS. The larger the number of your servers, the lower your MTBF, and the less meaningful machine failures really are.
So not killing machines then, but killing the canary, your new code.
Yeah, so what happens with canaries typically is that we don't kill them, we just take them out of traffic. So then you basically end up with, like, you had version 10 running, you tried releasing version 11, oh, that didn't work. You take version 11 out of production, out of traffic, but you leave it around because you will still want to run some experiments on it. Did I answer your question?
Yeah.
Good. Any other questions I can answer?
Do engineers ever log into boxes manually, or is it all done through infrastructure automation?
Engineers, it's an interesting and nuanced question, and I'll answer it in a nuanced way. Engineers can log into machines manually. Every engineer in Netflix, outside of our PCI environment, because the PCI environment in Netflix runs very differently from the rest of the environment, which, as somebody who has his credit card information that I'm pretty happy about. But in our non-PCI, non-SOX environment, which is like 99% of our infrastructure, everybody at Netflix has root on those machines. So they can log into those machines. It doesn't really happen. And it's not a sustainable way to sort of, do any work. And I'm not saying like it's not sustainable from a religious perspective. I'm saying it's not sustainable for engineers that we hire because we try to hire for laziness. So they can, but it doesn't really happen. Also, frankly, we recycle instances fast enough that if you made some sort of change on an instance, you're likely going to lose that change very quickly. I'm out of time on that.
Yeah, but I thought if people have asked more questions.
So I'm happy to answer more questions now. Otherwise, the pizza's right there, and I don't want to stand up to you.
Very wise.
And feel free to come up to me and ask other questions, especially because at that point I'm not going to be recorded. Right? So thanks for your time.